Waves on the Great Lakes have a lot of power, and you think about the waves generated by wind.
Has over the centuries earned a reputation for a place where all kinds of weird things and disasters have taken place.
Shorelines along the Great Lakes shifted, surprising those near them. Beaches pulled back, docks rose out of the water, and boats listed on their moorings within minutes. Accounts came from Munising, Duluth, Thunder Bay, Algoma, and Point Iroquois, with harbour logs and buoy stations showing matching changes at some sites. Officials checked weather records, pressure sensors, and harbour gauges to match the timings. But these weren't just isolated glitches or tall tales. The strange rhythm of water rising and falling appeared in multiple towns, recorded, verified, undeniable. So what exactly unleashed this eerie surge? What happened on June the 21st, 2025, Lake Superior? On the 21st of June in the year 2025, several shore towns along Lake Superior reported sudden changes in water level.
Lake Superior is astonishing. It holds 10% of the world's fresh water. It's the same size as North Carolina.
That surprised the residents and boaters. People in Munising, Michigan, posted a video showing the water pulling back from the beach and then rushing back within minutes. In Duluth, Minnesota, multiple boat owners filmed small craft slamming into pilings while docks sat above the water for short periods. Residents in Thunder Bay, Ontario, shared clips of large waves striking the marinas. In Algoma, Ontario, beachgoers posted photos of stones that were dry and then wet again a short time later. Near Point Iroquois, Michigan, pictures showed the shoreline looking different before and after the event. Federal and local gauges recorded changes on the same date. The National Oceanic and Atmospheric Administration, the Great Lakes, Environmental Research Laboratory stations, and nearby harbour gauges showed minute-by-minute swings at several sites. Harbour masters in Duluth and near Munising reported quick surges that moved moored boats and tore at lines. One Michigan marina filed a damage claim listing broken planks and damaged mooring gear. County emergency personnel inspected docks and recorded structural checks in reports that named the affected piers and marinas. Many videos posted on social media carried exact names of places and timestamps that helped officials match them to instrument records. Other clips had no information on time, which made verification impossible in those cases. State and provincial offices asked residents to send time-stamped footage and exact locations so that specialists could compare the timings to gauge logs. Where videos matched the gauge records, agencies treated those reports as verified events and began doing inspections. Verified matches helped narrow the list of likely causes at those specific sites. Weather radar and land pressure sensors showed a fast-moving line of storms over parts of Lake Superior that day. Researchers compared the timing of sharp pressure drops and bursts of wind to the minute-by-minute gauge records. At several stations, the pressure falls and the water swings occurred at nearly the same minute. That timing suggested a weather-driven wave traveled across parts of the lake. Radio interviews quoted fishermen who said the gear shifted without warning, and boaters who felt a sudden, short push of water with no long swell beforehand. State and federal agencies checked for other possible causes as well. The United States Geological Survey reviewed seismic records and did not register a major earthquake near Lake Superior on the 21st of June this year. Dam operators and port authorities reported no emergency releases or breaches linked to the events. The Michigan Department of Environment, Great Lakes, and Energy and provincial offices in Ontario reviewed buoy and harbour data and checked on where instruments showed sharp swings. Whenever those instrument graphs matched time-stamped videos, the agencies described the observed events as short lake waves likely driven by fast weather changes. Media outlets released names of towns, harbours, and marinas involved and quoted harbour masters and county officials. This information helped officials gather more time-marked evidence and additional damage reports. Harbour masters provided lists of vessels needing repair, and port logs detailed mooring damage at specific docks. The mix of confirmed sites and unverified posts drew wide attention across the region and prompted further laboratory checks before final conclusions were released. Officials collected data from Duluth Harbour, the Munising Station, Point Iroquois, and other nearby buoys to build a clear, minute-by-minute timeline. Those station records helped scientists find the exact period when water rose and fell, but the question still lingered. What invisible force could cause such sudden rises and falls in the water? Could these strange patterns be linked to something far greater at play? How seiches and meteor tsunamis work. Seiches are waves that move inside a lake. They start when water is pushed or pulled in one area and then swings back and forth. A seiche can tilt the whole surface of the lake a little. That tilt makes water rise along one shore and fall along the opposite shore. The change can happen in minutes or over hours, depending on the lake's size and shape. Meteor tsunamis are a type of seiche caused by the weather. When a narrow line of strong wind or a fast pressure change moves across a lake, it pushes the surface. That push can lead to a wave that travels far from where the wind is. The wave can grow when it meets the edge of a bay or a shallow spot. The same weather line that makes a meteor tsunami can pass quickly, so the water moves fast with little warning. The shape of the shoreline and the underwater land matter a great deal. Long bays and narrow harbours can focus a wave. Shallow areas slow the wave and can make it higher. Deep basins spread the wave out. The way the bottom slopes and where the lake drops off will change how the water moves. Small differences in the lake bed can make one harbour much more vulnerable than the next harbour a few miles away. Timing between weather sensors and water gauges is the key test. Scientists look at minute-by-minute changes in air pressure on land sensors and on buoys. They then look at minute-by-minute water level records at nearby stations. When the pressure drop and the water jump match in time, that is strong evidence that a meteor tsunami, or seiche, caused the water change. National Oceanic and Atmospheric Administration teams and labs use this check to confirm events. Seiches can also start from earthquakes. A strong quake will move the ground, and the water moves with it. That motion can set a standing wave that lasts for many hours. The United States Geological Survey keeps records of earthquakes and posts the time and location where they occur. Scientists compare those records to water station logs when they suspect a seismic cause. Instruments that record lake motion include fixed harbour gauges, buoys, and tide stations. Many of these instruments sample every minute or even faster. High-frequency data show the quick swings that people saw in posted videos. Researchers use graphs of these data to mark exact minutes when the lake level rose or fell. Not every pullback of water is a meteor tsunami. Wind set up over long hours can change water levels slowly. River flow, sudden boat wakes, and dredging can change the water in small places. That is why officials check multiple data sources before naming a cause. Predicting where a meteor tsunami will strike is still hard. The weather features that cause them are narrow and move fast. Weather radar, pressure sensors, and high-speed models help, but they can miss small lines of wind. Scientists are improving models by using more buoys and more detailed maps of the lake floor. That work helps to find which bays and harbours will likely feel the strongest effect. When a meteor tsunami, or seiche, happens, the water moves on a short timescale. The event can be over in an hour, but the effect on a harbour or a beach can be strong in a few minutes. That fast change is what surprised people on the 21st of June this year at several points on Lake Superior. Researchers will keep matching videos to instrument records to make clear how the waves formed and how each place responded. Historical records show seiches on the Great Lakes going back decades. Researchers and government officials study past events to learn these patterns. They use sonar maps, wave buoys, and computer runs to test how a storm line moves across the water. Researchers visit harbours to inspect damage and to measure how a bay amplifies a wave. But storms and waves aren't the only forces shaping the Great Lakes. In recent years, nature struck with a different kind of threat, one that disrupted daily life. How dangerous was it? Other Great Lakes events, 2023 to 2025. Between the years 2023 and 2025, the Great Lakes region had several events that caught public attention. Lake Erie saw large harmful algal blooms in the years 2023 and 2024 that closed beaches and affected local fishing. The National Oceanic and Atmospheric Administration, Great Lakes, Environmental Research Laboratory and state agencies issued seasonal forecasts and advisories for Lake Erie in those years. Officials from the Ohio Environmental Protection Agency and county health departments posted guidance on swimming, fishing, and beach use when toxin tests rose above safe levels. This year, some tributary streams reported fish kills that prompted investigations. One widely reported case involved dead fish in Ishua Creek near Perry, New York.
The State Department of Environmental Conservation is now on the case of a large fish kill along a popular creek in the southern tier.
After residents saw nearby industrial activity, county environmental offices tested water and inspected nearby facilities. Great Lakes Cheese and other companies in the area cooperated with investigators, while county researchers measured oxygen levels and ran basic chemical screens. Some tests pointed to high nutrient loads and low oxygen pockets, while others required more sampling to be sure. County records show when crews collected samples and when labs returned results. Across the years 2024 and 2025, several coastal towns reported loud booms. Residents in Alpena, Michigan, and in Presque Isle, Pennsylvania, described sounds that shook windows and startled people on shore. Police and fire teams checked for explosions, downed power lines, and aircraft incidents. In one case, military training schedules and radar tracks matched the time of a reported boom, and officials identified a sonic boom from a jet as the source. In other cases, no clear source was found, and inquiries continued. Local utilities and transportation offices released statements when they completed checks and found no damage. Some communities reported strange lights on the horizon on nights without storms. Observers in parts of Ontario and northern Michigan posted photos and short videos. Civil aviation authorities and the police collected witness statements and radar logs when they could. In many cases, the lights were later linked to fishing vessels, distant aircraft, or reflections from industrial lighting. A small number of reports remained without a clear origin after checks. Reporters asked officials at the Michigan Department of Environment, Great Lakes, and Energy, and at provincial ministries in Ontario for comments. Those officials provided dates, testing steps, and contact points for residents to report problems. Newspapers and television listed specific marinas and beaches that had been tested or inspected. The events that occurred during that period did not show a single cause across the whole region. Harmful algal blooms on Lake Erie are traced to nutrient runoff and warm water in the shallow basin. The death of fish in small streams was linked in some cases to industrial discharge or to natural low oxygen after heavy rain. Loud booms sometimes matched military or aircraft activity. Agencies handled each case separately and used field teams to collect the data. Officials set up hotlines and online forms for reports. Laboratories ran dissolved oxygen tests, nutrient assays, and chemical screens. Field crews measured water temperature, took sediment samples, and logged results. Where tests showed pollution, officials opened formal files and notified facility owners. But while the reports poured in and officials scrambled to connect the dots, a deeper question began to emerge. Could these strange patterns point to something far bigger than anyone expected? The data and official findings. Government agencies and officers looked for facts after the wave reports. The National Oceanic and Atmospheric Administration, Great Lakes. Environmental Research Laboratory posted water level graphs for stations around Lake Superior for the 21st of June this year. Those graphs showed quick rises and falls at selected sites. Harbour gauges in Duluth and the Munising station recorded swings that matched several videos. Ontario buoy data from Thunder Bay and Algoma recorded similar short changes in water level at nearby sites. Researchers compared weather station pressure readings to the water level graphs. Pressure sensors showed fast drops and rises that moved along a narrow line of storms across parts of the lake. Where pressure changes matched the gauge changes, officials considered a weather-driven wave a strong possibility. The National Oceanic and Atmospheric Administration officials and researchers use those time matches as a key check. The United States Geological Survey reviewed seismic records for the day. The seismic feeds did not show a major earthquake near Lake Superior. That ruled out a large seismic trigger in most locations. Dam operators and port authorities checked records and said there were no emergency releases or failures tied to the main events. County emergency managers filed reports where docks showed damage and where marinas saw shifted gear. Harbour masters and marina owners submitted lists of damage to local authorities. Those logs named specific docks and boats with broken planks, frayed mooring lines, and shifted vessels. Repair yards provided repair estimates and work orders. Newspapers and regional broadcast stations reported those lists and named the towns where damage had been logged. That reporting gave officials more time-stamped information to compare with gauge records. Lab technicians tested water and checked for pollutants where the death of fish and strange watercolor were reported in other parts of the Great Lakes.
Being researched underwater equipment.
That's right. In the tests are dissolving.
Those tests used dissolved oxygen meters, nutrient screens, and basic chemical assays. On the 21st of June, shoreline wave cases. The lab focus was on gauge time series and weather links rather than on toxins. Station names were included in public posts from agencies. For example, the Duluth Harbour gauge and the Munising station appeared in agency summaries. Agency pages allow the public to set a date range and view minute-by-minute data. That access made it possible for researchers, reporters, and residents to see the exact minutes when the water shifted. Where data and video matched, the event at that site was treated as verified and included in official reports. Officials emphasized that each clip must be checked against instruments and records. Where the data matched the videos, the likely cause in many sites was a short lake wave driven by fast-moving weather. Where instruments showed no change, officials kept the case open and continued to collect more data and witness statements. Official reports will be published when full station reviews and damage assessments are complete. But even with careful reviews and official statements, many felt something didn't add up. If nature alone wasn't responsible, what deeper forces could be shaping these mysterious lake events? Questions people ask. After the unusual lake events, people raised many questions. Here are the most common ones that triggered people's thoughts. Could an earthquake have caused it? Earthquakes can create waves in seas and lakes if they are strong and near the water. But on the 21st of June, the United States Geological Survey recorded no earthquake near Lake Superior or the other Great Lakes. The nearest seismic activity was too far away and too weak to disturb such a large body of water. This rules out earthquakes as a cause. Could a dam or control structure have failed? A dam break or sudden release of water would explain a fast rush into harbours. Even so, the Great Lakes do not depend on large dams to control their levels. Flow between lakes is managed gradually through locks and smaller control structures, not through emergency releases. On June 21st, no facility reported a failure or sudden discharge. Engineers confirmed that water levels in connected rivers stayed normal. This means dams did not play a role. Could a sinkhole under the lake cause the pullback? Sinkholes are known in smaller lakes or in limestone regions where water eats away rock below. However, Lake Superior's bedrock is mainly volcanic and very stable. For a sinkhole big enough to draw back a visible shoreline, it would leave major cracks or sudden collapses nearby. No such evidence was seen along the affected areas. The geology makes this explanation very unlikely. Could human activity like dredging or blasting be responsible? Harbours often carry out dredging or pile driving, which can stir up water, but those works move water only locally and do not cause a broad retreat across kilometres of shoreline. On the 21st of June, the changes were seen across different towns, not just inside one port. That rules out human construction work as a source. Could a meteor strike have caused it? A meteor hitting water can throw waves outward, but it would also cause light, noise, and sometimes even shock waves in the air. On that day, no fireball or strike was reported by radar, astronomy groups, or residents. A meteor is not the cause. Was it linked to aircraft or military activity? jet booms can rattle windows.
Great Lakes this afternoon, Chopper 7 over a large police response there. Officers apparently surrounding
And even disturb small ponds, but they cannot move lake water on a large scale. The swings in Duluth, Munising, and Thunder Bay were too wide and lasted too long to match a short air shock. Aircraft noise was reported, but it did not line up with the biggest water movements. So, what was it? The most likely explanation is fast-moving weather disturbances that created pressure changes across the lake. These changes can trigger meteor tsunamis, or seiches. On the 21st of June, in the year 2025, air pressure sensors showed dips and jumps that matched water gauges. That timing is the strongest evidence that wind and pressure, not quakes or human action, drove the strange waves. The questions remain important, but the data points strongly toward a natural weather-driven event, not an unknown force. The Great Lakes may hold their answers in science, yet the mystery still lingers. How much do we truly understand about forces shaping them? As research unfolds, one thing is clear: nature's power can surprise us in ways we least expect. Stay curious, stay prepared, and don't forget to like, subscribe, and join us for the next deep dive.